All right, so the last thing that I wanted to show you for section 5C is just kind of a neat little trick that's really helpful, especially as you go on through calculus. Let's just say, we'll kind of think of this as a puzzle. So let's say that I tell you that cosine of theta is 4/5. And so I'm not telling you what theta is, and you don't know what theta is because if you look at your unit circle, cosine is the x-coordinate. We don't have any terminal points on our unit circle that have 4/5 as the x-coordinate. All right, and I'm also going to tell you that theta is in quadrant 4. And I'm going to ask you to find sine of theta. All right, and there's a couple of ways to do this. I'm going to show you kind of a trick using reference angles. So I've told you that theta is in quadrant 4, and I don't know where it is, so theta is some angle like this. Okay, so cosine, it makes sense that cosine is a positive 4/5, right? We had our little mnemonic device that said that cosine should be positive if you're in the 4th quadrant. But how in the world am I going to find sine just by knowing cosine without knowing what the angle is? And the answer is through reference angle. So remember that my reference angle for cosine attaches to the x-axis. It's the acute angle that attaches to the x-axis. All right, and because, because theta is acute, it can always fit in a right triangle. So I'm going to make a right triangle that involves theta prime. Okay, because an angle, theta, and its reference angle, theta prime, they always have the same sine and cosine, right? That's why we were using the reference angles to figure out which terminal point, which numbers to use. Okay, the only difference is that theta might be positive or negative based on its quadrant. Theta prime is always acute. It's always a 1st quadrant angle. Okay, so I know that because cosine is 4/5, then cosine of theta prime is also 4/5. Right, so I'm going to draw, remember that for my SOHCAHTOA, I can make that right triangle follow the cosine pattern for 4/5. So cosine is adjacent over hypotenuse, so I'm going to make this 4/5 my adjacent side divided by my hypotenuse side. So I'm going to make the adjacent side 4 and the hypotenuse side 5. Okay, so as long as that ratio is 4/5, I can put any numbers that I want to on that right triangle. And then I'm just going to figure out this other side. We'll call it b. I'm going to say 4 squared plus b squared equals c squared. Oh, c squared is 5. Okay, so I've got 16 plus b squared equals 25. I'm just going to solve, subtract 16 from both sides. B squared equals 9. Hey, this was nice. Usually we get some sort of nasty square root. Okay, we get this nice 3, 4, 5 triangle. Okay, so then from the triangle, I can tell what the sine of theta prime is. Sine of theta prime is opposite over hypotenuse, so that's going to be 3/5. Right? And that means, remember that theta and theta prime have the same sine and cosine. So the sine of theta will also be 3/5. That's going to be the number. It's like I found the terminal point for theta prime. But my answer might be negative. I need to go back and check my mnemonic device over here, my ASTC. Okay, I'm down in the 4th quadrant where cosine is positive. That means that sine of theta must be negative. So I'm going to put a negative sign on my answer. Sine of theta is negative 3/5. Okay. So theta and theta prime always have the same sine, cosine, and tangent. It's just that theta might have a negative sign on it. We kind of have to pay attention to that. So let me do one more of these. All right, so I'm going to tell you, say I have an angle. You're given that tangent of theta is equal to -3, and that theta is in quadrant 2. All All right, so theta is in quadrant 2. So I'm going to draw the easiest thing I can draw, quadrant 2. There's my theta. All right, and oh, I didn't even give us a question. Let's see, let's find cosecant of theta. Okay, this works for going from any angle to any other angle, sorry, any trig function of an angle to any other trig function that you might want. Okay, so again, I'm going to build a right triangle with my reference angle. Okay, so let's put this guy in a right triangle, because I know that the tangent of theta prime is the same as the tangent of theta. Now I wrote 3, a positive 3 on there because reference angles are always acute, which means they're less than 90 degrees. If I were to draw that theta prime in standard position, it would be in the first quadrant, and that would put us in the first quadrant of our little mnemonic, ASTC. Okay. Sine, cosine, tangent of reference angles are always positive. They always lose that negative value. Okay, so I'm going to think of that, I'm going to think of that 3 as 3 over 1. So again, I'm thinking about my SOHCAHTOA. Tangent is opposite over adjacent. Okay, so I'm going to make my opposite side 3 and my adjacent side is 1. And then I'm just going to fill out that triangle. Okay, 1 squared plus 3 squared equals the hypotenuse squared. Okay, that's 1 plus 9 is 10. This one isn't as nice as the last one. My hypotenuse is the square root of 10. All right, and that allows me to find whatever trig function I would like to of theta prime, and because of my ASTC mnemonic, I can also find it for theta. All right, so they asked us for cosecant. I'm doing this all for theta prime right now. So for cosecant, I need to know sine so I can flip it over, right? Okay, so sine is opposite over hypotenuse. So I'm going to say my opposite side is 3, my hypotenuse is root 10. So that means I'm going to flip that over for cosecant, root 10 over 3. All right, so that's my cosecant of theta prime. And then all I have to do for the cosecant of theta is say it's going to be the same number, but maybe I have to put a negative sign on it. So I'm just going to double check. Okay, so cosecant came from sine, and in the second quadrant where I am, sine is positive. Okay, so if sine is positive, then cosecant is also going to be positive. So for this one, I can leave my answer positive. Okay, so to get from one trig function of an angle to a different trig function of that angle, we're going to pass through the reference angle, use a right triangle, and then maybe put a negative sign on there. All right, so that's all for this trick. That's the last question on your 5C homework, and let me know if you have any questions.